We've all been there. It's 2 a.m. and you get that dreaded alert. Pipeline run failed. It is one of the most universal frustrations for anyone working with data. You thought everything was perfect, but somewhere, deep in the system, something broke. So today, we're going to get to the bottom of it, for real.
So let's just ask the big question right up front. Why do these incredibly important systems seem so, well, fragile? Why do they really break? Is it a bug you wrote? Bad data? Some random network glitch? The truth is, it's a little more complex than that.
Yeah, it's almost never just one single thing. A data pipeline is a process, right? It's a whole chain of events that all have to go perfectly. A failure? That's just one link in that chain snapping. And when it does, boom, it causes a whole cascade of problems down the line.
So to really get a handle on these failures, we need to think of our pipeline like a factory's assembly line. Come on, let's take a walk. We're going to go right from the start to the finish, from the raw materials arriving to the finished product shipping out. And along the way, we are going to find every single potential point of failure.
Okay, so our journey starts right here at the factory's front door. This is ingestion. See, before we can do any of that fancy transformation or analytics, the raw data has to actually arrive, and arrive safely. If it can't even get in the building, well, the entire assembly line just grinds to a halt.
All right, let's look at the usual suspects you'll hit at this stage. First up, a simple connection timeout. You know, this often isn't some super complex code issue. It's usually a physical barrier, like a firewall blocking the way or a VPN that's not configured right. Next, authentication failure. This is basically your pipeline showing up to the door without the right key. You got to verify its identity, its permissions. And then there's the really sneaky one, source schema changed. The whole structure of the data just changes without any warning, and your entire process breaks because it's expecting the old format.
So, the big takeaway for this first stage? It comes down to a simple but really powerful checklist. Is the network path clear? Are the credentials correct? And is the structure of the data exactly what you expect? You nail these three, and I promise your raw materials will make it through the front door every single time.
All right, let's head on to the factory floor. The raw materials are in, and now the real work begins. This is transformation. This is where we clean and shape and enrich the data to turn it into something actually valuable. It's also, you guessed it, where a lot can go wrong.
This is where all the logic lives. And you know what they say, bad logic creates bad data. The most common error? A data type mismatch. You're trying to shove a piece of text into a number field, it's just not going to fit. Then you've got nulls. Your code is expecting a value, but it gets nothing. The whole thing just crashes. But you know, the most dangerous ones are the silent business logic errors. These are these subtle flaws in your calculations. The pipeline doesn't even crash, it runs, it says success, but it's spitting out the wrong numbers. That is just insidious. And that's exactly why you have to rigorously test your logic with tools like dbt or PySpark. It's not optional, it is absolutely essential.
So the mindset here on the factory floor, it has to be defensive. You have to assume data types are going to be weird. You have to expect null values and have a plan to handle them gracefully. And you absolutely cannot just trust your business logic. You've got to prove it's correct with tests.
Okay, we've done it. Our data has been transformed into this beautiful, finished product. We're at the final step, the loading dock. All we have to do now is ship it out. Send it to a data warehouse, a report, another system. Simple, right? Well, not always. You can get a permission denied error right at the finish line. It's crazy. Your pipeline had the key to the front door, but it doesn't have the key to the loading dock. Then there's this classic problem, duplicate loads. Say a job fails, and you just rerun it. Whoops! You could accidentally load the same data twice, messing up all your numbers. The fix here is to design for something called idempotence. It's a fancy word, but it just means running the process multiple times has the exact same result as running it just once. And finally, you can get partial or corrupt files if the process gets interrupted halfway through. That's why using techniques like atomic writes, which makes sure a file is either written completely or not at all, is so incredibly important for data integrity.
So for this final stage, your whole focus is on guarantees. Guarantee you have the right destination permissions. Guarantee your design is idempotent so you can rerun it safely without creating a mess. And guarantee your delivery process is atomic, so those final files are always complete and never corrupted.
Let's just pause on this number for a second. 4. Oh, 3. If you've ever managed a data pipeline, or really any cloud resource, this number probably gives you a bit of a headache. It's one of the most common and, frankly, most frustrating errors you will ever see.
It officially means resource not authorized.
What the system is telling you is, hey, I know who you are, but you are absolutely not allowed to do what you're trying to do. See, it's not that your password is wrong, it's that you're just not on the guest list. I'd say 9 times out of 10, maybe even more, this is just a missing role-based access control permission. It's the digital version of a bouncer looking at you and saying, sorry, not tonight.
Okay, so we've walked the entire assembly line, from one end to the other. But here's the thing. Sometimes the problem isn't on the line itself. It's deeper. It's in the factory's foundation, these big, systemic issues that can cause chaos literally everywhere.
Yeah, these are the big picture problems. The infrastructure itself can just fail. Your compute cluster runs out of memory. The scheduler can flake out. A trigger doesn't fire when it's supposed to. A security token can expire, and bam, everything gets locked down. And maybe the worst of all, your monitoring can fail. Because if you have no logs and no alerts, you have no idea a problem even exists until an angry user calls you. These foundational issues, they are often the absolute hardest to debug.
Okay, we've seen all the ways things can go sideways, from a tiny little permission error to a massive infrastructure meltdown. So what do you do? What's the repeatable playbook you can pull out the next time that dreaded pipeline failed alert hits your inbox?
Here it is, a simple 4-step process for any debugging session. Step 1, isolate the stage. Where on our assembly line did it break? Was it ingestion, transformation, or loading? This immediately narrows your focus. Step 2, read the logs. Seriously, don't just guess. The error message is your single best clue. Step 3, check identity and access. Remember that 403 error? Yeah, it's so common it deserves its own dedicated check every single time. And finally, step 4, validate the data. Ask yourself, is the problem really in my code, or is the raw material I'm getting the real issue?
Following that playbook will help you fix any broken pipeline, and do it fast. But it leads us to a final, and honestly a much bigger question. You fix the immediate problem, great, but have you made the system better? Your pipeline is fixed, but is it truly resilient? Because fixing today's break is good, for sure, but designing a system that anticipates and gracefully handles tomorrow's failure, now that's the real goal.